So we're going to start off with you guys giving a little introduction to who you are and why you're here. Probably not half an hour each, more like half a minute each. But can we start at the back?
I'm starting. So my name is Eduardo Mario Mendiondo. I am water resources engineer. I was born in Argentina. An Argentinian living in Brazil, it's not an easy question, even when we are playing soccer. My main field is water security under change. So I'm a professor at the Department of Hydraulics and Sanitary Engineering at the São Carlos School of Engineering. And also I am very open to this interdisciplinary approach and participatory approach of water governance under change. So I'm very, very excited to assist your classes, Professor Howard Witter and Patricia Gover. Thank you.
Thank you.
Then to translate my? Oh, okay. Yours.
No.
Okay.
No,
Okay.
eu falo pra você.
Então, fala seu nome, então.
I'm Pedro, and eu sou estudante de mestrado.
Hey,
This is
Pedro.
master student at
Yeah.
this university.
Eu estudo vazamentos em redes de abastecimento de água.
Okay, he's studying the leakage of water in some water distribution systems.
Okay.
And you are, você veio da onde?
Eu sou de Minas Gerais e sou formado em engenharia civil.
This is a civil engineer from Minas Gerais State. Okay? É isso mesmo? Ok. Muito obrigado. Muito obrigado. Thiago?
Hi, my name is Thiago. I study here environmental engineering. My research today is thermal behavior using green roofs and green facades. I study here in USP, and my research here in USP as well.
Okay. I have a green roof on my house, so we're friends, right?
Hi, my name is Monique. I'm an environmental engineer. I graduated here last year. I'm currently doing my master's at a Oceanographic Institute back in São Paulo. So probably I'm the only one with a focus on oceans and coastal ecosystems. And my research currently is for environmental characterization of the Santos Bight here on the Southern Ocean. But I have interest to know about water resources management on coastal ecosystems. That's why I'm here. Thank
Great.
My name is Ademir. I am from Federal University in São Carlos too. My interests are now low impact development. We are studying how we transpose the barriers when you want to transpose, use advanced technology in urban drainage, or you are using sustainable technology in urban drainage. We are working in, ciclo de vida, life cycle to. This is what I work now.
Okay, thank you.
Hi, I'm Felipe. I'm a PhD student here in the Department of Hydraulics and Sanitation. I got my master's degree this year on March. My background is on civil engineering. I finished my undergraduate in Federal University of Mato Grosso do Sul. And then I moved to São Carlos to study here, University of São Paulo. And since then, I started working with hydrological systems. Yeah, that's it.
My name is Brunella. I'm from UFES at Espírito Santo. I am master student in environmental engineer.
Hi, my name is Larissa. I'm from UFMT, Cuiabá. I study master in water resources, and my dissertation is in overview and water systems in Mato Grosso. I work in planning, the planning, the sanitation in Mato Grosso, and my master in the nesta linha, in the field. Yeah.
Hi, my name is Telmo. I graduated in law school, and I did my master and my PhD in law, environment law also. Then I went to start a new graduation in Federal UFSCar in social science, and now I intend to study the new regulations and the new sanitation and postdoctorado here in USP.
Great.
And it's a pleasure to be here to see what's the engineers, things, and all that. Thank you.
Hi, Professor. My name is Marcos. I have a background in civil engineering, and right now I'm pursuing a PhD here in University of São Paulo. In my master, I'm studying low-impact development techniques, especially the bioretention, looking to hydrological and hydraulic models to assess its efficiency. And yeah, I think it's an opportunity to see your presentation, and that's why I'm here right now.
Thank you.
Hi, my name is Calil. I'm from Goiás and center of Brazil. I have a bachelor degree in civil engineering from University of São Paulo. I spent some time in Canada. I have heard about how cold is Saskatchewan, and I worked a time in a consultant firm and water resources. And in Canada also I worked with water resources related things, and that's how I started my interest in this topic. And I started last year my master degree here in the University of São Paulo in this program, and I'm working with hydrological modeling, and that's it. Thank you. I'm pleased to be here, and I expect to learn a lot in this week. And thank you for coming.
Thank you.
Good morning. My name is Gabriela. I'm a graduate student, and I hope the next year I will study here. And I want to work with hydrological security and in climatic changes scenario. That's it.
Thank you.
Good morning. I'm Julian. I am a PhD student here in the University of São Paulo. My research interest is ecosystem services and the economic relationships between them. And I'm also very pleased to have you here in Brazil, and I'm very excited for your presentation. I think it will be very helpful for everybody. And I'm also studying Canada for almost 2 years in Toronto, University of Toronto. And Canada is my second home, and I think I hope you be comfort here in Brazil, and you have a very good stay here.
Thank you.
Hi, my name is Gabriela. I didn't study in Canada yet. I'm a PhD student here. I study insurance as an adaptation measure for climate change, but my big picture studies water security and climate change, and I'm very interested to hear you too. So thank you for coming.
Thank you.
Hi, good morning. My name is Cesar. I'm sanitary engineering. I studied in Federal University of Pará, and I'm a master's student. And my project is about flood insurance in a climate change, using climate change scenarios.
Hi, my name is Yuri. I'm from Sergipe, from the northeast of Brazil. I studied civil engineering at the Federal University of Sergipe. I'm a master's student from here on USP, at USP. My field of interest is hydrometry, and I am working with low-cost instrumentation for measurement of river flows.
Thank you.
Her name is Lisette.
Eu sou da Colômbia.
She's from the Colombia, Bogotá.
Eu estou fazendo mestrado.
She's a master student.
E eu trabalho vou trabalhar com a avaliação do risco de escassez de água para futuro cenário de mudanças climáticas.
And she will work with evaluation of risk of water shortage, considering future scenarios of climate change.
Great. Thank you.
Hello, my name is Ana Carolina Gashmer Marx, and I'm a master's student from São Paulo State University, Unesp. I'm an environmental engineer, and I study the geophysics applied to hydrogeology and the impacts of society and urban I forgot. And the impact of society in groundwater. So it's very interesting for me to be here to hear about the two mainly topics. So thank you.
Hi, my name is Bruno. I'm a master's student here as well in the hydraulic and sanitation program. And I'm a civil engineer. I graduated last year in Sergipe as well as Yuri. And I came from Bahia originally. And in my project, I'm going to work with including social, how can I explain? Including people into a scenario of best management practice application. I'll create the scenario using people's information.
Thank you.
Hi, good morning. My name is Natalie, and I'm an environmental engineer, and I finished my master's at USP in São Paulo about water flow measure. There in São Paulo, I work at Sabesp. It's the biggest company of water sanitation in Brazil, and to have an idea, we have to supply water for about 13 million people in the metropolitan region of São Paulo.
Yes. Great.
Hi, my name is Douglas. I'm a public relations. I've been working with sanitation for 23 years. I work at the same company as Nathalie. We have just met, okay? It's a huge company, so as I said, I've been working with sanitation for 23 years, always in contact with public policies for sanitation. Nowadays, I am a PhD candidate at Unicamp, State University of Campinas, at Department of Science and Technology Policy. The focus of my research is specifically policies, ecosystems that develop ecosystems for startup companies to grow into the sanitation sector. I believe that much is pretty much it. Thank you for Professor Mediondo and Felipe for for accepting my application for this week. Thank you very much.
Hey.
Only to check the summary of this self-presentation. We have here people from 3 countries of South America, and from Brazil, we have people coming from 11 states, from all the areas, northeast, north, southeast, southern part, and central part of Brazil. So all Brazilian territory, potentially speaking, is being represented here through this audience. Okay?
And also quite a wide range of disciplines. So with engineering as a strong background for many, but also people working in law and insurance and
of course.
public
Geography.
engagement and so on. So I think one of the messages from this introduction is that you should all talk to each other and learn from each other as the course progresses. Okay, so just where are we on timing? We have the rest of the morning.
Yes, perhaps 45 minutes, 1 hour speaking, and after that we break from some questions. Because this is not only a lecture, it's a plenary room about questions.
Yeah, okay.
Ideas, and brainstorming things.
So I'm going to give a fairly generic introduction to some of the issues that we're facing as society at the moment. And then I'm going to talk about what that means for us as students and researchers moving forward. And I'm going to illustrate, using in this talk, Canadian examples of some of the challenges and some of the progress that we've been making. You've all talked a lot about your background, so I started off life making aero engines for Rolls-Royce, and then I became a hydrologist a very long time ago, and worked first of all on problems of urbanization and its impacts on flood hydrology. I was at Imperial College for 32 years, and I was head of environmental and water resource engineering there, which has a very strong international program, and I had quite a large number of Brazilian students, some of whom are academics in Brazil right now. And then, and my focus really was on how we need to use science to solve a range of societal problems. And so I worked on everything from acid rain to nuclear waste to agricultural land management, groundwater resources. I did a lot of work in the Middle East on very arid areas, and I'll talk about that on Thursday. Then I had the opportunity to go to Canada, and Pat and I moved in 2010 to take up faculty positions at the University of Saskatchewan. So I was able to create quite a large integrated program based around an institute that we founded, the Global Institute for Water Security. And we were then able to expand our horizons from focusing on the west of Canada to a very large program called Global Water Futures, which is worth several $100 million and includes many academics from across Canada and across the world. And then Pat and I retired from Canada about a year ago, and we're now primarily based in Arizona in the winter and in the UK in the summer. But we're still very much working with colleagues in Canada and students and postdocs there. So that's a little bit about my background. Let's just talk about some of the issues of water. As you're all aware, I think, water has got many different dimensions. And as Pat alluded to earlier, very often these are compartmentalized. But if you're a water manager, you face all of these challenges. This is a a picture from Bangladesh, and that's an interesting story. Clearly there are issues of water availability, and clearly there are issues of flooding in Bangladesh, but also Bangladesh has a major problem of groundwater quality, and it's sometimes called the world's largest mass poisoning, because there was a major program to develop shallow groundwater for drinking water, and it was not realized that the groundwater is very strong in arsenic. So arsenic pollution has been a huge issue. People have had cancers, amputations. It's a very tragic story. So that encapsulates quite a number of issues around water quality, limited water supply, and floods, particularly for poor people in the world who have very few resources to manage their way through these crises. The next picture really relates to the relationship between agriculture and water. And many of you will know that something like 85% of the world's consumptive use of water is for agriculture, and in particular irrigated agriculture. So agriculture is a huge user of water, and it's a major factor in water resources in many areas of the world, and not least Western Canada. So we're used to talking about agriculture and food and water. We're also used to talking about energy and water, and it's pretty obvious that hydropower and water are strongly related, and there are a lot of issues around that. But perhaps what's less well known is that any thermal power plant also needs cooling, and so water is a major issue for power generation. And there was a major drought in Europe in the 1970s, and France had to start turning off its nuclear power stations because it ran out of cooling water in the rivers. So relationships between water and power include not only hydro generation, but thermal generation. And then the other relationship between power and water is that water is heavy, and it uses a lot of energy to transport water. So the biggest user of energy in Arizona is pumping water. So we're used to thinking about the water, food, energy nexus. But there are many other aspects that we need to be aware of too. So pollution is an issue, and certainly in the UK, the biggest generic problem of pollution is from agriculture, and it's mostly to do with nitrates. And there's a lot of issues around nitrates in groundwater and in surface water, and the challenges of trying to regulate agriculture around that. In Canada, there are huge issues of legacy pollution from mining activities. Some of the cities in the north are sitting on very large deposits of heavily contaminated waste materials. And as the north warms, then the opportunities of mobilizing those resources are great. But all around the world, there are major issues of managing wastes in the environment. The environment itself and ecosystems are important, and probably the biggest challenge that we face at the moment is trying to maintain adequate water for ecosystems. And the statistics on the loss of biodiversity, particularly in freshwater systems, are really frightening. So it's a real challenge to maintain sufficient water in our freshwater systems, our rivers and our lakes, and also to maintain groundwater that in turn feeds wetlands. So there are huge challenges around that. And then flooding is the other part of the water story, and there are many examples every year of major flooding issues. And right at the moment, the north of the UK has just had a whole sequence of really severe storms, and so there are communities that have been flooded out of their homes over the last month or so. But I'm sure if you read a newspaper, then scarcely a month will go by without some major flood disaster appearing. Here are a few images just to highlight some of the challenges that we face at the moment. So the Aral Sea is probably one of the widest used examples of the over-abstraction of water, and the story is that there was extensive use of water for irrigating cotton in the former Soviet Union, and that has dried out the Aral Sea, so it's now about 10% of its natural area. Floods. Floods are often conceived of as a local issue, but increasingly with the global community and global trade, they can have much wider consequences. So you may remember the floods in Thailand in 2011, and they shut down a huge component of the world's semiconductor manufacturing industry. So you couldn't buy computers in the United States because of the floods in Thailand. I've already talked a little bit about arsenic in Bangladesh. We quite often focus on water quantity, and very often water quality is not spoken of with nearly as much prominence, and yet it's a huge issue in terms of public water supply, but also in terms of industrial and agricultural pollution. Floods and droughts, there are lots of examples. California has had a very severe sequence of dry years, and so that's led to major shortages of surface water, and in response, agriculture, interestingly, has maintained much of its production, and California feeds most of the USA, and the way it's done that is by increasing abstraction of groundwater. And there are major issues around groundwater and its lack of regulation in California. And groundwater in California is also associated with subsidence. So in the Central Valley, there have been up to 10 meters of land subsidence over decades due to over-extraction of groundwater. So even in Trump land, floods occur due to extreme weather, and Mr. Trump doesn't acknowledge the role of climate change, but the rest of us do. And the US has suffered some catastrophic events, and Houston was just one recent example. And it's another interesting example about the interface between the natural environment and the human environment, the urban environment, because Houston was allowed to develop with very few planning controls on the location of development. And that's really one of the reasons why it suffered catastrophic losses from this major event in 2017. I talked a little bit about nutrients. So we, as a society, push a huge amount of nutrients into our aquatic systems, both surface water and groundwater. They come from sewage, and they come from agriculture, and from other sources too. But the consequences can be quite high. Lake Winnipeg is one of the world's 10 largest lakes. It's in Manitoba in Canada. And it's at the end of a river called the Red River, which originates in the United States and then flows north into Canada. And so it had major issues of nutrient pollution. About half the nutrients come from agriculture in the States and half from agriculture in Canada. So it's quite a complicated river system, and algal blooms have been one of the consequences of that. And algal blooms are interesting. They are obviously unsightly. This is a tourist area, but also they damage ecosystems. And some of the algal blooms are toxic. You get toxic blue-green species, and so animals get killed if they drink water contaminated with toxins from algal blooms. So it's a health hazard too. These are just a few of the examples of current issues. Canada is an interesting country. It's a huge country. It's the second biggest country in the world, and it has a relatively small population. And it's one of the most water-rich countries in terms of amount of fresh water per capita. But it has all of the problems that I've just been talking about, particularly in the west. So we've had some major floods, and while we were living in Canada, the centre of Calgary went underwater with some very important economic consequences. Intense floods in Toronto caused major damage. The prairies where we lived are interesting because they really suffer from a very extreme climate. I mean, winter temperatures can be -30, -40, and summer temperatures can be +30, +40. And amazingly, it's the breadbasket of Canada. It's 80% of Canada's agriculture is there. But it does suffer from droughts. And in fact, when it was first explored by Europeans in the 1850s, there was a man called Palliser, and he said it's really much too dry to think about developing it. But another expedition went along 15 years later and found a luxuriant prairie environment. So it is now the home to Canada's agriculture, but it still suffers from droughts. And I think drought is probably the major source of water insecurity in Western Canada. I've talked a little bit about algal blooms in Western Canada in Lake Winnipeg, but the Great Lakes have an interesting story because they suffered from algal blooms, and quite a lot of work was done to, in the 70s and 80s, to uncover the cause of that, and a lot of that was due to phosphorus in detergents. And so a major program was put in place to change the way in which people use phosphorus. And that started to resolve the nutrient problem, but it then re-emerged, and that essentially is due to agricultural fertilizers. And the situation at the moment is that some of the Great Lakes are quite severely impacted, and much more needs to be done. There are a lot of rural communities in Canada, and in particular, a lot of First Nations Aboriginal communities, and many of those have really complex issues of inadequate water supply and sanitation. And there are all sorts of social issues around that. Problems of lack of investment, but also problems of difficulty in providing the manpower resource to maintain these systems. But the result is quite shocking that at the time I put this slide together, more than 1,000 communities were impacted by inadequate drinking water quality. So, some of the issues in Canada. So, this is just telling you all probably what you already know, but the fact is we do have a water crisis pretty much everywhere in the world. There's a huge amount of overuse of water, there's a huge amount of contamination, and yet we're facing massive change, and the change is taking place through social change, and but also through climate change. So for all of us in this room, we're interested in how to manage our way forward. Canada is an interesting example for Pat and I to work in, because climate change is really playing out in a very big way there. So Canada, as somebody said, is a cold place. And the water resources are really determined by processes of snow and ice, glaciers and so on. And Canada is losing its cold. So most of you will know that warming is greater in the higher latitudes. And winter minimum temperatures in Western Canada have gone up over the last 60 years by 6.5 degrees C. And one of the consequences of that is that there's up to 2 months less snow cover in the year than there used to be. So in the north of Canada, we have a lot of permafrost that is thawing. It's giving major challenges for communities, and it's also changing the landscape. So we're having ice lenses in the soil thawing, the landscape is collapsing, forests are then falling over and turning into wetlands. There's new kinds of hydrological connectivity occurring as the permafrost is thawing. In the prairies, there's a very interesting story, because the prairies are pretty arid, they're semi-arid, And some years they have very little runoff, and some years they have quite a lot. But that runoff has traditionally been snowmelt in the spring. But the last 10 years, we've seen intense summer storms, which people have never experienced before in their lifetimes. And that's given some major infrastructure problems, as well as affecting agriculture. The kind of canary in the coal mine for coal regions is glacier retreat. And the Rocky Mountains in Canada are a huge water source for rivers flowing to the east and the west and the north and the south. And the glaciers are shrinking very fast, and they'll mostly be gone by the end of this century. And that's important because it's the glaciers and the glacier melt that maintains the low flows in the rivers. And so there's a big question mark about the future of those river systems and their low flow conditions. There's an interesting story in the Yukon where warming actually led to a river changing its direction of flow. So this was a river which was fed by a lake, and the lake was dammed by a glacier. The glacier melted, lake flowed the other way, and the river changed its direction, which was a huge issue for the indigenous communities whose livelihoods depended on that. And then something I haven't mentioned as yet, but wildfires, I don't need to tell you about this, but wildfires are a huge issue in Canada. So Pat and I have been living in Saskatoon, which is a couple of hours north of the US border, right to the south of Canada. But we've had the city of Saskatoon under days and weeks of smog because of forest fires 400 or 500 miles up in the north and the northwest. And some of you may remember that there's a city called Fort McMurray, which was the heart of the oil sands industry, and that was completely wiped out a few years ago by fires. And people were very lucky to escape with their lives. And of course, after fires, there's a tremendous legacy of contamination of the surface and of water systems. So those are Canadian examples. Of course, recently we've seen issues in California, and right now Australia and Sydney, even Sydney is being threatened by wildfires. So a warmer climate has huge implications for the environment in many, many senses. So what should we do about this? Is it business as usual for what we do as researchers and students? Well, I think, first of all, we need new science because we have to understand change. And most of what we do in terms of designing water infrastructure is really based on recent history. If we're lucky, we might have 30 or 40 years flow data, maybe 50 or 60 years of precipitation data. That's what we tend to use to design our infrastructure, but that's no longer an adequate basis because things are changing. And the changes are complex, as we've seen. They're changing ecosystems, the whole land surface is changing, and that has feedbacks to water systems and also feedbacks to the atmosphere. Another big thing is that all of these issues that I illustrated are complex problems involving many aspects of society, and all of them involving people. So we really need to do a much better job at bringing together communities of researchers to work on these complex systems, and also engaging with people who are facing these challenges in their daily lives, and the people, of course, who have to manage these systems. So we need to do a much better job at capturing the interconnections and integrating our research to address user needs. There's, of course, a tremendous tradition of scientific endeavor to study problems for their own sake, and that is wholly worthwhile, but we have to recognize the need for focused research to address these user needs. And as an engineer, that's something which has been a major motivation for me in my career. And something that probably Pat will talk about later in some detail is the challenge of linking science to policy. And very often we have a major disconnect First of all, there are challenges within the policy arena itself, because we've seen that water affects so many aspects of life. It affects land management in particular, as well as water management. And we're really not very good at joining those different elements of planning together. But also, we tend within the science community to work in our own silo and talk to ourselves, whereas we really need to put a lot of effort into working with people who have these challenges. They can give us a lot of insight into the nature of the problems, and if we expect them to take our results seriously, then they have to be informed as to what we're doing and why, and how it can be relevant to their lives and their livelihoods. So there are some big issues for us as we move forward as a kind of community of graduate students and researchers at the moment. So I'm going to turn to Canada and explore a little bit about how this is playing out with what we were able to do in Canada. So Pat and I went in 2010. We were given $30 million to play with, and so we set up an institute at the University of Saskatchewan, and that institute currently draws on 26 different academic units. So we've been able to use that money to bring people together, but really people only work together if they focus on the same problems in the same places. So we used as our primary playground our local river system. So I came from the UK, and you've all heard about the River Thames. The River Thames has a catchment area of 10,000 square kilometers. All right, it's so this is our local river system in Saskatoon, 406,000 square kilometers. Well, these large sizes are meaningful for you in Brazil, but for people from Europe, this is a shock. It's an interesting basin because most of this is semi-arid. It's the prairies that I was talking about. 80 to 90% of the water supply comes from the Rocky Mountains, so it's dependent on snow and ice. And then the water flows eastwards. So here's the city of Calgary, which is the kind of hub of the oil industry in Canada, and located on the South Saskatchewan River tributaries. Here is Saskatoon. And interestingly, this river system feeds into a major wetland area here. It's called the Saskatchewan River Delta. It's about 10,000 square kilometers. And then drainage from that goes into Lake Winnipeg, which I already spoke about. So some of the issues. In Alberta, the water is wholly used. So there are no spare water resources. So there's a major push to try and make irrigation more efficient and to make more water available for environmental flows. We've seen that climate change is playing out in quite complicated ways. So we've talked about the retreat of the glaciers. We've talked about the changing precipitation in the prairies. And as we move further north, we've talked about the impacts of permafrost change. So big issues. Although there aren't many people, there's a lot of agriculture. So we have all the problems of eutrophication, primarily due to agriculture rather than sewage in our situation. We've had some major extreme events, both floods and droughts, and if we look at scenarios of the future, or even stories from the distant past of centuries past, we see much more extreme droughts in the past, and certainly we expect droughts and floods to increase in the future. And the water governance in Canada is quite fragmented. So there's very little central federal control. Most of the control lies within the provinces. And so this is a river basin that rises in Alberta, flows through the province of Saskatchewan and then into Manitoba. And it also has some interactions with the USA. So it's a complicated system where the different provinces tend to have different water management structures. So Alberta, for example, still has first in time, first in right water rights, whereas Saskatchewan got rid of that. There are some rules which are kind of tablets of stone that came down from Mount Ararat with Moses, but around about the 1960s. So half of the natural flow from Alberta has to be released by Alberta to flow to Saskatchewan, and half of that natural flow has to be released to flow to Manitoba. There's been some really interesting challenges around water quality because there are rules about water quality for everything except phosphorus, because phosphorus has been so difficult and challenging and problematic, and I'll talk a little bit about that later on. So water governance is kind of organized by these simple rules with respect to water flow. Water quality, there are still some outstanding challenges, and there's a big issue about whether, in fact, as we move to a warmer future, whether that governance model and those simple rules are adequate. So does it make sense to use, as we do, 85% of the water for irrigated agriculture in Alberta, when in fact one of the users downstream is hydropower? So if we didn't use the water in the province of Alberta, we could use it in Saskatchewan and Manitoba for hydropower. So those sorts of technical discussions can't take place in an environment where the flows are prescribed as they are. One of the themes that both Pat and I will talk about is the link between people and the water environment. This is the city of Saskatoon, and it's a beautiful city, particularly in the summer. It's really wonderful. Has a great jazz festival in June. And this is the South Saskatchewan River flowing through the city. Upstream, there's a very big dam, Lake Diefenbaker. At the time, it was the largest earth dam in the world, and that has completely changed the flow. So the black line is the natural flow regime prior to the construction of that dam. So you get spring snowmelt in the Rocky Mountains. The water flows through the downstream tributaries and gives you the summer peak, which is great for irrigation. That's when you need the water. Now, the dam is built partly for irrigation, partly for hydropower, and it's actually changed the flow. So we now get the lowest flows in the summer and the highest flows in the winter. And that really is important in terms of that wetland. I talked about the wetland at the bottom of the system. So that was inundated seasonally. In fact, the indigenous communities that lived there typically were isolated for 4 to 6 weeks every year because their communities were only available by water, and the landscape was flooded. Those summer floods have gone, and there are dams upstream, and the river is degrading. It's cutting down into its bed. So even if you get the same flow, it's not going to do the same amount of flooding. So there's some real challenges about the ecosystems and the people whose livelihoods depend on those ecosystems. Drought is a big deal. So drought you will know about from the recent history here, but the last big drought in the prairies was 1999 to 2004, and it had a huge impact on agriculture. And some very interesting things happened then, because I mentioned that Alberta had this first in time, first in right water rights. But actually, there was sharing of water. So senior white rights holders made water available to junior rights holders so that communities could continue to function. It's no use producing food if the food processing industry has not got enough water to process it. So there was some interesting stories about that. Floods, we've had many since we arrived in 2010. In fact, 2010 itself was a record rainfall in Saskatoon. But particularly Calgary going underwater was a major issue with about $6 billion worth of direct damages. So, you know, the major heartland of this major industrial capital underwater. Now, why was that? It was because the planners had ignored warnings about floodplain zoning, and they chose to build in vulnerable areas. And in fact, this is a story, this is a picture of a community called High River, and after the floods they knew why it was called High River. This is a water quality story, which is quite interesting. I talked about the difficulty of transboundary agreements about water quality. So this is a slide that maps out phosphorus concentrations over a period from 1973 to 2009. So we've got the Rocky Mountains here and the city of Calgary, and we've got the blue lines showing very low levels of phosphorus. The red line was the guideline for acceptable levels of phosphorus in water, 50 milligrams per litre. So as we move through the heartlands of Alberta, we start to see levels increasing, particularly on the Red Deer. And then these rivers then converge. So here's the Red River just before it gets into Saskatchewan, and then all of this nutrient finds its way into Lake Diefenbaker, and then rather little of the nutrient leaves Lake Diefenbaker. So Alberta had this big challenge because routinely its phosphorus levels were many times higher than the guidelines. So the solution of that is to abolish the guidelines. Seriously. So in fact, they're still negotiating a transboundary agreement, and it will be based around the status quo and not making this current situation worse. So it's really a failure of governance to try and manage this challenge. Agricultural management is a really interesting issue in the prairies because the prairies are a curious landscape. They're very recent, recently glaciated landscape, and so they have thousands and thousands and thousands, hundreds of thousands of small depressions, and when it rains, they fill up with water. They're called prairie potholes. And this is the natural landscape after an intense period of rainfall. And the farmers don't like that. They would like to see something like this. So what they do is, of course, drain the landscape. So about 80% of the prairies are drained. And that has lots of advantages for agriculture because you've got more areas to be productive, and you can get onto the land with your heavy machinery, irrespective of the weather conditions and so on. But it reduces a lot of natural storage, and it reduces a lot of natural attenuation for nutrients, and it passes on the water to somebody downstream. So in the last 3 years, Saskatchewan has finally recognized the challenge here, and it's introduced some new legislation which requires all historical drainage to be licensed. Not just current drainage, but historical drainage. So this is a major challenge, and they don't really have the tools or the techniques or the manpower to do it, but it's an attempt to try and recover the problem of downstream flooding. And it's also something of a transboundary problem because the province of Manitoba has been complaining that Saskatchewan is flooding Manitoba through land management. So land management is a big deal in the prairies right now. I talked a little bit about climate change. That's the temperature signal of observed temperatures across the basin as a whole over the last century. So it's highly variable, but it's only going in one direction, and that is warming. The glaciers are disappearing fast. This is a diagram that shows the net change year on year. So from 1960, it's all negative, and 2015 was a particularly bad year, but actually the last 2 years have been very bad as well. So the glaciers are really moving back fast. Pat and I did a trip to the Rockies summer before last, and it's spectacular to see where the glaciers were even 10 years ago and where they are now. They're retreating into the far distance. This is an interesting story about one of our experimental basins in the prairies and showing the history of flows over the last 30 years. And the color shows the origin of the flow. So blue is a flow that's generated by snowmelt. So as I said, historically the prairies have been dominated by snowmelt. And some years they have no flow, and some years they have quite a bit. We get some mixed rain on snow, but then there are some rainfall floods. And in the last few years, we've had these major episodes. So there's just a huge increase in the amount of runoff from these basins compared to the relatively recent past. And that raises a lot of challenges for local communities. The hydrology of the system is quite interesting because most of the natural flow in the major rivers flows from the mountains. But we have all these local depressions draining the prairies, and much of that area does not connect to the main river system. So there isn't really anywhere for this water to go except to be stored and flood agricultural land and local communities. So these are the challenges. What do we do about it? Well, we decided that we would build on and strengthen an infrastructure for observatories. So the first thing, as Pat was saying this morning, is you want to manage something, you've got to understand it, you've got to monitor it. So we have a number of observatories in the Rocky Mountains, and actually this slide is a little bit out of date. We've got something like 50 observing sites in the Rocky Mountains, mostly run by John Pomeroy's team, and John actually has a little site office in the foothills of the Rocky Mountains at a place called Canmore, and some of you will know Martin Clark. Martin's now living in Canmore and managing that outstation. We've got boreal forest up here, and so there's some quite important sites located in the boreal forest that have been running since about the 60s. So we've been maintaining and expanding and updating them. And then several sites in the prairies themselves, St. Denis, Kenaston, Smith Creek I already showed you down here. And then I spent quite a lot of money on Lake Diefenbaker, trying to sort out the nutrient story for Lake Diefenbaker. Remember, we've got all this phosphorus coming in and not too much coming out. So there's a vulnerability to change there. So here are some of our Rocky Mountain sites. This is what they look like. This is what they'll look like at the moment. Some big issues, complex issues around snow in the mountains. It's highly heterogeneous. There's a lot of issues of blowing snow, which redistributes the snowpack. There are a lot of issues about interaction with vegetation. So John Pomeroy has a weighing tree here so he can measure intercepted snow on that. This is what the boreal forest sites look like. So flux towers looking at water energy and carbon fluxes with 15-minute data back to the 1960s. Those have been a huge asset for us. And the prairie sites do different things. Smith Creek was looking at drainage. This is a site that was set up to look at this potential for remote sensing to monitor spatial soil moisture. So it's got nests of dense observations of soil moisture. And then this is another site close to town, St. Denis, which is a really an ecological site as its primary focus, but there's quite a bit of hydrology being put in to explore the dynamics of the pothole systems and how they interact. These potholes are quite interesting because the shallow potholes, they just dry and wet every year, but the big ones have got a longer term memory. But the little ones drain into the big ones. So you've got this kind of gatekeeper that you get a sequence of wet years, the whole system wets up. But if the big lake at the bottom dries, then nothing flows out. So most of the hydrological models for the prairies really fail to reproduce that complexity. This is the Lake Diefenbaker studies. We've been doing some interesting work with remote sensing, And drones have been a big deal for us, and John has now got with our current funding, a new drone lab to extend this. But if you're looking at snow processes, then even with a relatively simple drone like this, you can get spectacular high-resolution visual images which allow you to map the snow, of course, but also by differencing to get the snow depth changes. And something that we're playing with at the moment, which is really interesting, is the SWOT mission. So we've persuaded SWOT to... SWOT is a satellite mission that is planned, which is going to measure water elevations from space to relatively high resolution. So for medium to large rivers, you can actually measure water level from space. It's not yet flown, but they have airborne missions, so we're persuading them to fly our region. And Al Petronero is doing some interesting work to look at the potential of that. That really could be revolutionary. We've done a lot to develop modeling capability. The real challenge in Canada, and I guess it's the same in Brazil, is we don't know what the rainfall is. It's a huge area. We have very few people in the country as a whole, but very, very few people in the north. So it's very under-observed. And bearing in mind, you've got the mountain topography and all the complexity. So one of the things that we're doing is using high-resolution atmospheric modeling to get insight into the precipitation processes. So this is, we've done 4-kilometer WARS simulations for the whole of Western Canada and currently the whole of Canada, working with NCAR in Boulder, Colorado. And those have been very insightful. We've done a lot of hydrological modeling, and because we're working at large scales on these basins, we're able to use gravity satellite data as a tool to help us constrain our hydrological models, and that's been really interesting. So the amount of information you get from a flow measurement is quite limited, but remote sensing gives you some spatial structure, and GRACE gives you a measure of total water storage, albeit at relatively large grid scale. So we were able to get we found if we fitted our models just to flow data, we could get systematic biases. If we started to introduce the additional information from GRACE, we could constrain the models much better. And this is a diagram that shows our model parameters fitted to our basin and the spread of uncertainty. These are all feasible model parameters. And you can see quite large spreads for the different parameters of acceptable values. If we use that additional data, it constrains the uncertainty in the parameters. So that's been quite a nice story. One of the problems in modeling large systems is to represent human impacts. And we've got something like 56 dams in this system, mostly little, but the big ones like Diefenbaker too. So we've done quite a bit of work to develop algorithms for large-scale modeling that we can train using available flow data. And we've tested those on various dams, not just in Canada, but through North America and the rest of the world. So that's something that's now incorporated into our large-scale hydrological modeling. So we're working a lot with Environment Canada has a model which they call MESH. So it's really one of these large-scale models that can be embedded within a global climate model, but it also has some hydrological add-ons. So we're doing a lot of work with this MESH model, and it allows us the capability to simulate current and future climate. The challenge for future climate is getting the forcing data at the right resolution from scenarios of future climate change. We've also been doing work to learn from the past. So tree rings have been important, and I talked about the history of flood and drought in the prairies. Well, with tree rings, we can not only go back from the observed record, which in the prairies is the early part of the 20th century, but we can actually go back to 1600 using tree rings. And that's been important because it shows us that the droughts we've experienced including the 1930s Dust Bowl, were exceeded in the not too distant historical past. So even where people are skeptical about climate change, as they still are in the prairies, you can say, well, just look at the long record. We've had severe problems to work with in the past, and they will recur in the future. We've done a lot of process response. So this is work on frozen soils. So to get things like permafrost thaw right, you've really got to understand not just the water movement, but the thermal properties. And you get this cycle of annual freeze and thaw. And that, of course, changes the physical properties of the soil moisture hugely. So that's very important. We're doing a lot of work on that. So our observatories feed data into these process studies. Our observatories also show us some of the strengths, but also some of the weaknesses of the climate models. So I showed you those sites from the boreal forest, where we were measuring water, energy, and carbon fluxes. And if you plot observations of relative humidity, wind speed, and temperature on the observed data, then this is the kind of picture that you get. But if you look at what the models are producing, then they're really different. So there are some major challenges still in trying to improve the capability of our climate models, which is, of course, the tool we're mostly using to look at future climate change. We've had this big challenge of how to model the prairie environment. So I had two good ideas when I went to Canada, and one of them was how to represent those using a stochastically distributed storage, and that's now built into the large-scale modeling and does a much better job at reproducing those non-contributing areas and their dynamics. People in the prairies don't talk much about groundwater because it's out of sight and it's out of mind, but it's interesting. So most of the groundwater in the prairies is very old and rather saline. There are a few aquifers, such as one that provides Regina with its water, that are good, but they tend to be slowly recharged. So if you withdraw them down, it can take years or decades for them to recover. But one of the things that's going on is a lot of industry, potash mining in particular, is putting its wastes down into the ground, into deep groundwater systems. And that's giving rise to challenges. So in fact, there is a ring of earthquakes moving out from these potash mines because this stuff is just put down there and it's put down there and it's got nowhere to go. And something also that we've been looking at is using some of this saline water for industrial purposes. So rather than having to rely on surface water for processes such as fracking, for example, which is a big deal, we can use saline water instead. There's a lot to do on the aquatic ecosystems, and this is a seasonally frozen environment, and so all the lake ecologists really like going out on their beautiful lakes in the summer when it's nice and warm, and that's where all the data comes from. So there's very little information about the ecosystem dynamics under frozen conditions. So we've been doing quite a bit of work, colleagues like Helen Bolsch, to understand those processes. And there is really quite a lot of biological activity taking place through those closed winter periods. Turning to the water resource side, then one of the things we did early on was to try and produce a tool that we could work with stakeholders to look at scenarios of change. And so we produced a spreadsheet-driven model of the South Saskatchewan. This is the inflow to Saskatchewan at the Alberta border, and we can change this. We can look at the effects on Lake Diefenbaker, the flows into Manitoba. We can increase irrigation area, which is what the agricultural people would like to do, and then we can look at the consequences. So there's a big tension between plans for irrigation development and some of the needs of downstream communities. We've been doing quite a lot of work on thinking about how to handle the future. So typically people take climate models, which are very uncertain. They feed them into hydrological models, which are quite uncertain, and they put them into a water resource systems model. So there's a big cascade of increasing uncertainty. And sometimes the uncertainty is so large that it's not really useful. I mean, an obvious example is if we're not sure whether it's going to be wetter or drier in the future. So we've been doing quite a bit of work to look at system vulnerability. So let's postulate a range of possible changes in the future. Let's explore the sensitivity and the vulnerabilities of our river system and our water resources to that. And then we can make some sensible comments about economic viability of future developments. And here is some work by a student of Pat and mine called Elmira Hassanzadeh, where she was looking at kind of distributions of hydropower generation under scenarios. So this is the current situation where we've got millions of dollars value of the hydropower generation in the province of Saskatchewan. And then if we reduce the flows, as might occur under one scenario, or we increase the flows, we can look at the distribution of economic values. And then we can superimpose irrigation development and see what the trade-off is between irrigation economic gains and hydropower losses. And interestingly, it's something of a win-win, because you can get more hydropower out of the system without taking too much of a hit on agriculture. So with Pat arriving in Saskatoon, she was very keen to develop work on the social sciences. And one of the first things that we did was to set up a project where we worked with stakeholders across the river basin from Alberta right the way through to the First Nations communities in the Delta to understand their perspectives. And Pat's working with a student at the moment, Hayley Fowler, who's taking that further to look at what people's alternative views and perceptions are of water futures. So you can't read this in detail, but industry has one view, environmentalists have another view, indigenous people have another view, and those proposing irrigated agriculture have another view. So there are these conflicting views, and there's a question of how they can map out into sustainable futures that needs to be explored. And we've done a lot of work on in the Delta working with First Nations communities, which is quite a complicated process because those communities themselves are quite fragmented. There is some misunderstanding of the real issues. For example, there's a major dam just upstream of the wetland, which is being used for power generation and including peak power pulsing. But actually the main change of flows is really down to the upstream dam at Lake Diefenbaker. But one of the consequences of the changing flow regime has been a huge impact on natural populations of animals like muskrats. So muskrats were really plentiful, 140,000 in the 1950s, and they're almost non-existent now. And there are also issues around moose and elk populations too, as well as fish populations. So there's a lot of work been going on to work with the community to understand their challenges and the ecosystem challenges, and then to try and translate that through scientific analysis to explore different ways in which the ecosystem might be managed. And that's currently being played out because the dam just upstream is up for relicensing, and so this information is part of the relicensing story, and hopefully there'll be more sustainable releases of flows for that. So this is a little diagram that's been put together just to sort of highlight the interactions in this system. So we've got complicated interactions between the hydrology and the vegetation and the wildlife and the fish. And of course, it impacts people's livelihoods. Traditionally, their livelihoods were hunting and trapping and fishing, and now it's a lot of tourism around that. So that is impacted by the hydrology, but also by the changes that we see to the wetlands and the wildlife associated with it. We tried to get the message out in broader ways. And this is a play that we put on called Downstream, which was a lot of fun. We played it in different places, and it's interactive. So there's a kind of panel that makes decisions, but they're advised by the audience, and the audience votes. And there are various stereotypical characters. So we have an environmentalist, we have an oil man, an oil producer, we have an agriculturalist, and we kind of play out the issues around trying to manage extremes. So it was a lot of fun, and a lot of people who really knew nothing about water gained a lot of insight into some of the challenges that we find in trying to meet different expectations. We've also been doing a lot of work with First Nations, and that includes training them to monitor the health of their environment. The big issues for the First Nations are really, is the water safe to drink, and is the food safe to eat? And these are communities which lie downstream of the oil sands in some cases, so there are a lot of concerns about impacts of that. But there are other issues too. For example, we have radioactive lakes in the north of our province because of uranium mining in the 1950s being really badly managed. And so those are unsafe areas. So a lot of challenges around heavy metals and other environmental factors. Okay, so I've talked about the challenges to the world that we all face. I've talked about how they're playing out in Western Canada, a water-rich area. I've talked about how we've tried to mobilize a research effort to move forward with various dimensions of that problem. I've got a little more to say about what subsequent developments that took place, in particular Changing Coal Regions Network, and then most recently a big pan-Canadian project called Global Water Futures. But this might be a good place to have a stop and a break, and maybe to ask some questions. Yep. Yeah, thank you.
Thank you for your very nice presentation and talk. I take a lot of notes to my own, and some of them I would like to share with you. But now is the moment of questions and brainstorming and suggestions. It was very easy to follow your presentation. Thank you, congratulations. And also to show up the Canadian state of art, especially with Saskatchewan River Basin and also observatories. So I know the audience here, they have several questions. They have some hungry and thirsty situations because we are very close to noon, but we have time. And the objective of the school is also to maintain this feedback from lecturers to the audience, and from the audience to the lecturers, as a way of brainstorming new challenges, a new point of view, and new projects.
Great.
Of course. So it's open. Okay.
Hello. Thanks for your speech. And I would like to know more about the way this social hydrology understanding you run this kind of thing, because the information are so technical, and I am interested in this contact between university and research and community. How we translate this kind of images in someone that is tasteful. I don't know how to say exactly, but understandable.
Okay. Well, Pat is going to give a whole talk on this. To do with work she's been doing, but I'll just say a little bit around that. I think the key is to put investment into people who can do this work, and so in the case, and that's difficult actually, it's difficult to find people. But we've made a couple of faculty appointments to work in this area, and one person in particular was Graham Strickett, was really very, very strong on building relationships with the user groups and finding innovative ways of elucidating their views and also exploring the issues. So the play that I showed, he got a grant from the Social Sciences Research Council in Canada to work with the drama department to produce a play. And so he was kind of thinking originally with originality about different methods of engagement. Another thing he did was to get funding for a traveling art exhibit working with the First Nations communities. So I've talked about the Saskatchewan Delta, but in the rivers to the north, there are other major delta systems with First Nations, all having similar concerns. And so he actually put on an art display, gathering material from the communities, and he traveled around all these regions explaining this. And so we did a lot of media. We've made quite a few films. We've done quite a lot of TV and radio. We've done quite a bit of newspaper work to try and raise awareness. Pat spent a lot of time trying to get off the ground an interactive observatory where we could bring people in and play with models, and she was all set up to do it, but we never, ever quite made it happen. The money was just never... There was a lot of interest, but it didn't translate into cash. So we've been doing a number of particular projects that have worked closely with communities. So I talked about the Saskatchewan Delta. So there's a lot of work done. A really nice team. I was kind of the boss, but I wasn't involved in the team. But we had very good aquatic ecologists, and we had social scientists and hydrologists all working together to kind of explore, what are the hydrological changes, how has the ecosystems responded to that, how did this impact on people's livelihoods, and then how could things be managed better in the future. So that was one example, and there was some modeling done to try and highlight that. We've also done some similar work with some farmers, trying to look at the impacts of drainage and drainage management. So we've done work with local communities on local issues, and then some of these stakeholder workshops trying to understand different perceptions. And they're quite interesting because there are political differences across the basin. So Alberta traditionally is quite right-wing and very pro-development, and it's the heart of the oil industry, so water and the environment are something that's a resource. And the complete contrast is the First Nations, where for them, water is something that's precious and it's a life force and it needs to be maintained at all costs as part of their cultural heritage. So there's a complete spectrum of views that one needs to be aware of. But I think the main challenge is finding the right people, and it's really difficult to find people who can bridge the gap between the social science perspective and the hydrological science perspective. We've been lucky, we've got just a couple in the group in Saskatoon.
During my master's degree, I analyzed 62 press releases published by the São Paulo state government during the water crisis of 2014, and from January 2014 through January 2016. And specifically related to this topic, to this issue that you brought up here, I was amazed by the role of public discourse for the way society perceives a water crisis. And I only could find that out when I outlined all those press releases in a timeline, and also when I put them together to the level of the Cantareira Reservoir. It's a huge reservoir we have in São Paulo system, Cantareira system, yeah. And when I saw this comparison, so I put them together, the level of reservoir with the press release published by the São Paulo state government. And I could realize that a water crisis is not only perceived, but also it is designed by public discourse. And from this moment, and when you have science speaking the truth to power for policymakers, and so they are responsible for public discourse, for conducting the population through an event like that, you have that situation in which you have social hydrology spoken to public policymakers, and then you have the public discourse being spread, the word spread around the population. So you have the crisis seen as an environment issue, a situation.
Let me just sorry, Pam.
Well, I think the answer to your question has already been answered well, but I would like to echo the importance of bringing in social scientists if they're sociologists or political scientists or whatever, to make the science policy interaction a research question in and of itself, deserving of funding, deserving to be published in the major journals of the field, because these are more than climate and hydrological issues. They're issues of human perception and engagement. I think a lot of times hydrologists, not you guys, but a lot of times people call me to their projects because they want to check off a box that they've got some social scientist working to politely engage the public. It's a different, you're going to attract a different kind of person when you attract somebody, a social scientist who has deep research interest in this process of making climate information or hydrological information more relevant and more likely to be used in societal decision making. And if we raise the social science to that level, then I think you're going to attract the kind of people that we want and integrate the kind of perspectives that they have into this science policy. So I noted you were a science policy guy from your introductions, and that's exactly the. I think that's the, we're not going to be babysitters for decision makers and make everybody feel good because they've been part of some illusionary process. This is going to happen as a byproduct of doing the business of social science, is my.
Let me just add.
It's very preachy, but I mean, that's what I feel.
We finished up. I'm not sure if I'll show these slides, but we finished up with a very large pan-Canadian project with a $150 million program. And the way we ran that program was to create areas that we wanted to see explored, and then we invited people to bid for research funding. And we made it a requirement that they had stakeholder engagement plan, and their research was only funded if their engagement plan was deemed by PAT to be valid. And then as part of the infrastructure, we appointed 3 or 4 full-time people whose role was to try and facilitate that linkage. So we're now no longer running that program, but it is rolling on, and it'd be interesting to see how successful that model has been. But it was a kind of combination of a stick and a carrot. So here's money, but you can only get it if you've got a sound engagement plan. Yeah.
So thank you for the brainstorm. So Kevin, from questions?
Hi, Howard. Thank you for your presentation. It was really, really insightful. I have a question that maybe it's not about what we are talking here, but I would like to know if you have any insights about it. Because I'm doing my master's in oceanography, I think I have like obligation to ask how marine water resources can be encompassed by the water security discussion. Because most of the times we talk about inland water, which is of course important because we have a constant connection with it because of how we use these resources. But when we talk about marine water resources, I think sometimes it's a different discussion, and most of the times they are not connected. So I'd like to know if you have any insights about it. Thank you.
Yeah, I think you're right. I have zero expertise in marine science, so I can talk authoritatively about this. But I think there are two communities of people, and they don't talk enough. Interestingly, one of our major focuses in Canada has been the Mackenzie Basin, and that actually is one of the biggest inflows to the Arctic Ocean. So we've been trying to sell our results as these are important because the freshwater inflows to the Arctic are huge. But I think there just hasn't been that level of interdisciplinary integration. So it's a very strong example of one of the challenges that I spoke about. Interestingly, I did get involved recently in reviewing some $150 million program for the Great Barrier Reef because I had experience of working with large programs. And I think they've done quite a good job in Eastern Australia in trying to integrate some of the challenges of land and water management with impacts on the coastal ecosystems. Although what they found is that the increased water temperatures and their impact has been much greater than the land-based issues, which are easier to control. So they were certainly aware of issues of sediments and nutrients affecting the barrier reef, but the bleaching has been overwhelming. So lots to do in that area, and it's just great that you're sitting here.
Yeah, more questions? Yeah.
Okay. You talked about the groundwater storage, and I wanted to know if you have mapped all the groundwater storage in this region, because you talked about the phosphorus concentration on the river water and the surface water, and the groundwater, how it is.
Yeah, well, that's an interesting question. I think in the 70s, there was quite a lot of money in the province went into a few major projects looking at groundwater, and there was some preliminary mapping of the major aquifers, and then really the money went away from that. And then I arrived, and really there was very, very little happening. And so I was working really hard to try and bring together the oil industry and the government of Saskatchewan and the researchers to try and move things forward. And it was very hard work, and we had limited success. But there are one or two projects going on. So we're working with one company, fracking company, to understand in detail the mapping of the aquifer in their region. I talked a little bit about Regina water supply. It's an interesting story. Regina was founded as a city because they were bringing the railroad out westward, and they needed water, and they stopped overnight, and they drilled a borehole, and they just managed to hit the edge of an aquifer. So they made a town there, and that became the city of Regina. But it's quite a limited aquifer, and full of fractures and not well understood. So I funded a student to kind of improve understanding of that, but it's really complex, and there's very limited data. So the simple answer is that there's a broad-scale understanding, but detailed mapping is very largely absent. Although another barrier is that there's a lot of information in industry which is confidential, and the requirements to make that information public vary by the industry, and they're generally inadequate. But if one could actually bring all that information together in the public domain, then a lot could be learned. Yeah. So I think it's a story where there's a need for investment in new projects, but also trying to overcome these barriers to information exchange.
Yes, because all this water is connected, so the surface water and the groundwater, so we can study all of them as a complex.
We should do.
We should.
I'm having a lot of fun in Chile doing that right at the moment. So we're working in the Altiplano, looking at groundwater-dominated systems. Yeah, yeah.
Just one, I was going to ask the results of that research you did with the participation of the public, but as you said, I think Patricia is going to talk a little bit more about that. I'm going to ask about the tool that you analyze the consequences of changes in agriculture or land use change. That tool you said, that program. What variables did you use? How was that built?
What we've done is to work on a small basin, Smith Creek, and we've done a lot of detailed observation of the hydrology, and we've done a lot of detailed modeling using a model that John Pomeroy developed that reproduces frozen soils and blowing snow and all those issues. And we've got a student right now looking at scenarios of change. Working with the stakeholders has been pretty challenging because there's pretty much a war going on the ground between parts of the agricultural industry who are very pro-drainage, and then some of the land is owned by a charity called Ducks Unlimited, which is a very big North American charity that protects wetlands so they can kill ducks. But anyway, it's a big charity and it's doing a lot of work on wetland preservation, and there's really a lot of friction between those groups. So there's so much tension that it's become a very difficult place for us to work anymore. And one of the problems is that we've got a lot of data from this one site, but it's not necessarily typical of the challenges across the prairies. And so I mentioned we've got this legislation coming in on how to manage drainage, and it's really, and so the effects of drainage in this basin are very dramatic, and the work has been done that clearly shows that. But the regulator, now called the Water Security Agency of Saskatchewan, doesn't believe that that should be universally applied, and they're quite right, but we just don't have a lot more sites. So it's a challenging area, but you need a good understanding of the hydrology and the impacts as the base for a discussion. I've done a lot of work in the UK on land use management, and I've learned a lot from farmers about how their environments function, and they've been very influential in coming up with ideas for more sustainable management. But they're very site-specific. Unless you really understand the local area, it's very difficult to understand what will work, because one intervention may be good in one area, but may be bad in another area. So it's a real challenging problem. I think land management is very local, and you have to have good local insights. And very often it's the people that have spent their lives, or maybe their families have spent generations living there, who understand better than a scientist coming in how these systems work. Yeah.
Okay. Thank you. You answered better than I thought.
Well, one decade ago, as a young, early career scientist, we have a joke that's in the former times we have a hydrological humankind rooted by models and so on, and joking for the future to say perhaps what will be the time when we are achieving a human hydrology from a hydrological humankind towards an human hydrology. So now we are discussing the human and water dimensions, the interactions, the feedbacks, the patterns, the coexistence, the coevolutions, and also the paradox.
Yes.
In your opinion, from this experience in Canada, what are the possibilities to expand your frontiers, to replicate your lessons learned, experiences gained to other countries, also in South American latitudes? Because we are different, because we have difference in terms of biomes, but we have people also facing same problems, the water insecurity related to economy, to social. So what are your opinion, and what kind of future you envisage of replicating some pros and cons in this experience?
Okay. That was my last slide, which I didn't get to. I think the issues are quite generic. We're facing some really complicated challenges to hydrological science because our baseline has been assumption of stationarity, and now we know that there are massive changes. There may be human-induced land use changes, they may be human-induced climate change, they may be changing water management, but what's for sure is that the past is no longer an adequate guide for the future. And there's some real difficulties in understanding what changes might take place. And even the models that we use to predict the future are actually based on an assumption of stationarity. So we really need some excellent science to understand the changes that take place, and that science has got to be running across different disciplines, not just hydrology, but ecosystems as well. And then we just have to do a better job at connecting, using social science expertise with society, and that has several different facets. One is, as you say, trying to understand the interactions and feedbacks. And we're really only in the early stages of recognizing that. So Gunther and CEFA have been doing a lot of work to kind of proselytize this, the need for us to try and, CEFA's been developing simple models to try and explore these societal interactions. Some very interesting work from Italy, Di Baldassari and others on flood vulnerabilities and so on. So there's a lot of work to be done to understand the interactions with society, and that work is in its infancy, and the data on the whole to support that work are very limited, because actually we have much better data on, even though it's imperfect, on hydrological flows than we do have on domestic water use and industrial water use and so on. So we really need more data and more understanding of those interactions and feedbacks. And then the other element of this is the dialogue of building a community that involves stakeholders, different kinds, users of information, embedding them in research. So it's not just a researcher delivering results, it's really results that are jointly produced. So those are quite generic models, but it's a really hard thing to do, because to engage stakeholders requires tact and understanding of social science methodologies as well as hydrological methodologies. And it takes a lot of time. So the First Nations communities that we work with have mopped up a huge amount of people's time. When they're not writing papers, they're talking to elders, Yeah.
Yeah. Well,
we have this big project, which I haven't told you about, Global Water Futures. And our first science meeting, we had a real challenge with First Nations. Because they accused us of having a funding model that was very unfriendly to them.
Of course.
They didn't want to engage, and they were extremely upset about it. And so we recognized that, and then we developed a special pot of funding for them, and we developed new methods of engagement and a different approach to assessing their projects, and we funded some work. And we had our first ever science meeting at the Six Nations in Ontario at their lodge. And it was a really wonderful, enriching experience, and all our young researchers were really impressed by understanding the issues of the First Nations, the role of their traditional knowledge, and the respect for their traditions and perspectives. So it was very worthwhile, but there was a lot of tension and heartache and effort that went in up to that point.
Yes, of course we have some very similar problems here in Brazil. We have Aboriginal Indian people. When we are facing them with some normal knowledge, they are not accepting them.
Yes.
So we need to reboot our computer and say, okay, we need to learn more. And of course, that is also the objectives of this school, is to make more dialogues through transdisciplinary science, and of course, to pave the floor for new thinking and a coevolution about not only hydrology, but also social science, geography, and so on. So thank you for your response. Thank you for the questions. I think we reached to the first part of our first day. That was very successful. I would like to thank also the staff and the people also coming from the following through internet, from the streaming. And I would like to invite you to have a break, to go for lunch. And Felipe, you have more about the schedule, when we are returning back.
Yes, the next lecture starts at 2:00. Okay, so it would be good if you could be here at 1:30 or 1:45. Okay, because I know some of you don't have the access to the building, and I'm gonna say that in Portuguese, right? Está aberto para fazer as matrículas no período da tarde lá na secretaria. As matrículas podem ser feitas depois da aula da Patrícia, tudo bem? Todos que têm já os documentos, alunos regulares, alunos não regulares, especiais, USP, não USP, podem se dirigir ao departamento de hidráulica. Vai ter várias pessoas indo para lá que são já da USP, eles podem guiar vocês, tá bom? E é isso. I think that's all for now. Thank you for the first time of the presentations. Thank you, Professor Howard. Thank you very much.